Whenever you're ready.
Okay. Human gene editing. I will be analyzing and arguing in support of human gene editing through the scientific and futuristic lenses. After looking through these lenses, I concluded that human gene editing should be allowed under global regulations in gene therapies to correct errors in DNA that cause genetic mutations and diseases such as AIDS, cystic fibrosis, sickle cell anemia, and various cancers. However, CRISPR technology should not be allowed to be used in germline treatments or genetic enhancement treatments. There are two types of gene editing, germline and somatic. Germline alters the genome of embryos at the earliest stages and affects all the cells in an organism, including the sperm and egg cells. Because of this, any changes made to DNA in germline treatments are passed on to the offspring. Currently, the FDA has more restrictions on germline than somatic. Somatic editing only alters the DNA of the patient being treated. The CRISPR technology is used on a specific set of cells to cure a genetic disease. This type of editing is not hereditary and therefore poses less of a risk. A risk of gene editing is mosaicism, the occurrence of two or more sets of cells in an organism. This mutation is more common when gene editing is used on an embryo, which is usually germline. Through studying animal test subjects, Harvard Dr. Frederick Asubel, PhD, discovered a strong correlation between mosaicism and CRISPR treatments. There are many consequences of mosaicism, including miscarriages, birth defects, developmental delay, and cancer. At Columbia University, Sam Sternberg, PhD, the assistant professor of biochemistry and molecular biophysics, is researching the possible future of gene editing in specialized treatments. His research is mainly focused on epilepsy and Parkinson's. Currently in the US, according to the CDC, 3.4 million people have epilepsy, a statistic that, if gene editing is allowed, would decrease dramatically. In Sternberg's research for epilepsy treatments, he uses CRISPR technology to analyze the morphology of mice brains. This helps uncover the causes of epilepsy at a faster rate and enables researchers to use CRISPR technology to develop more specialized treatments that can soon be applied to humans. In his Parkinson's research, he used CRISPR to identify how the variant gene glucocerebrosidase, or GBA for short, disrupts the production of enzymes. With the advancement of this technology, millions of people who suffer from genetic diseases would have the ability to be cured. While gene editing provides some benefits, there are also consequences that need to be considered before CRISPR technology is able to be used. There is controversy when it comes to the morality of altering a human's DNA. While some believe it is beneficial to research the cures of genetic diseases, others believe the risk of genetic enhancement is too great. According to this graph from Pew Research Center, you can see that the majority of US adults believe that altering DNA to cure a genetic disease or prevent a disease is okay, while there is still some hesitation, majority think it's fine. Here you can see that majority of US adults believe that altering DNA to make the baby more intelligent or mental enhancement is not okay. Another cause for resistance to gene editing is designer babies. While CRISPR has the potential to help cure and prevent diseases, it can also be used to design specific characteristics of a human, including gender, physical traits, intelligence, and personality. This could create a larger social gap within the social classes because genetic enhancement treatments would be very expensive and unattainable to the majority of the world's population. To conclude, after researching through the scientific and futuristic lenses, I believe that human gene editing should be allowed to cure and prevent diseases. However, the focus should remain on somatic editing because the risks of germline are too unknown. There should also be legislation in place to protect gene editing from the physical and mental enhancement. Thank you.
All right, thank you. A couple of questions. What evidence did you gather that you didn't include, and why didn't you include it?
Well, with the research for potential treatments from the Harvard doctor, there was a lot of interesting, more advanced things on how he uses CRISPR specifically in his studies, and I wanted to include more of that. Unfortunately, I just didn't have more time, but to really get how the future of CRISPR is in treatment, specialized treatments.
Okay, thank you. What additional questions emerged from your research?
I was really curious about more of the scientific community's view on CRISPR, and I wasn't able to research through all of that, but how the different controversies of that and how that has been setbacks, or how if they want to continue and society is holding them back.
Okay, thank you. Another round of applause.